Hello everyone, this is Vijay and welcome to my YouTube channel. Yes, in last videos of group theory, we discussed about definition, properties, example, and one of the most important theorem of group theory. Okay, now continuation of the theorems here, we are going to discuss an important theorem, that is uniqueness of inverse. Okay, so before going to the today's session, subscribe to my YouTube channel for more updates and follow me in Telegram for class materials, PDFs, textbooks, and previous question papers. In the description box I mentioned my Telegram link. Okay, now moving to the today's session.
Okay, now see here what is the statement. The inverse of an element in a group is unique. That means if G is a group, A is an any element of G, then A has one and only one inverse element. More than one inverse element does not exist for A which is in G. Okay, now but we prove this theorem in contrary way. That means if A is the element in G, but what we take here, B and C are the two inverse elements of G. B and C are the two inverse elements of G. But at last, what we prove here, B equals to C. That means here observe, what we take here, B and C are the two different elements, but at last what we get, both are equal. That means every element in G has unique inverse element. If you take B, C, D are the three inverse element of A in G, but last what we get, B equals to C equals to D. So what we observe here, every element in G has one and only one inverse element. Okay, now see the proof of the theorem. Here I am taking G comma dot, G comma dot be a group, G comma dot be a group, and small a is an element in G. A belongs to G is an element in G. It is an element in G. Okay, now what we prove here, now we prove that A has unique inverse element. A has unique inverse element, but we prove this theorem in contrary way. That is, if possible, what we take here, if possible, B and C, if possible, B and C are two different, these two are different, we are assuming here, we assume B and C are two different inverse elements of A. Okay, here B and C are the two different inverse of elements of A. That means B and C are satisfies inverse law with respect to the binary operation dot. Okay, by inverse law, what we write, A is an element in G, A belongs to G, there exists inverse element B belongs to G. By the condition of inverse law, A dot B equals to B dot A equals to A. This is equation number 1. Okay, in the same way here C is also inverse element of A. So right here, for all A belongs to G, there exists C belongs to G. That implies A dot C equals to C dot A equals to A, which is equals to 2. Here dot is the binary operation. Here dot is a binary operation. So always remember, if dot is a binary operation, the identity element is always equals to 1. Okay, from equation 1, what we write, B dot A equals to A. Next here I am multiplying with C on both sides. What we get, B into C equals to E into C. Okay. By the associative law, what I write, B into AC equals to, this one is by associative law and it is by identity law. By identity law, E value is 1. If you substitute 1 into C, C. So these conditions by associative law and identity law. Okay, now from equation 2, what we observe, A into C equals to E. A into C equals to E. So substitute here B into E equals to C. So B dot E. Again, E value is 1 with respect to the multiplication dot. So what we get, B equals to C. Observe here, what is our assumption? If possible, B and C are the two different inverse elements of A, but at last what we get, B equals to C. So if you take different elements, but at last what we get, B and C are equal. That means every element in G has unique inverse element, okay, this is one of the important theorem in group theory. Okay, thank you.